Hello and welcome back to Compiler Programming. In today's video, I want to take another step on the matching, and in particular, I want to prepare ourselves for eventual arrival of macros. And for me, a macro means that we will need to be able to match over specific syntax. So there are a lot of variations on the kind of macros you have. And for example, in Rust, you are only able to say, for example, like foo and then this exclamation mark that describes that this is a macro. And I'm not a huge fan of it. I think it would be really nice that you could introduce new syntax in a language without it looking explicitly like a macro. Like there are obviously arguments on both sides, but I think it is kind of neat that you can swap function call, for example, for a macro without any problems, or you can, I don't know, introduce new keywords if it makes sense for your use case. And so I'm not a huge fan of this option. Obviously in C you can do just a regular function macro or just replace any identifier with it. C macros are horrible in the fact that they're like the opposite of hygienic, so you constantly have to worry about stuff. You cannot really introduce like variables and expressions. So there's a bunch of bad things about C macros, but the fact that you can sort of replace any construct, or like not even any construct, like in C they're also limited that you can only replace sort of single identifiers. You cannot have multi-identifier macros, and you are limited with the function call style. So you can't, for example, turn this stuff into macro. Like you can't make that in C, and that's also quite bad. And I think it's same in Rust. You can't really do that. So you'll have to, if you want to make that part of the macro, you have to make the whole block part of the macro. And so, yeah, I really want a very flexible system here. And essentially, that should be the same system that is underlying all the regular stuff. And we already have the beginnings of it. I think there's going to be lots of problems with the ordering eventually, and how we want to resolve priorities and stuff. And maybe I will have to create an AST or some kind of intermediate representation. But all of that is going to be solved when it actually becomes an unsolvable problem, or when I realize how to do it very nicely. For now, the idea is very simple. I want to be able to introduce these kind of things in a more declarative way, such that we would be able to extract them out of the program and run them like that. So let's think how that would look like. Basically, we would have something like token match pattern, and it would return something like token match result, or pattern match, and we say token pattern match result. It will get something. I guess it will get this state, and it also, so the question is, how generic do I want to be? Because we have these two options. One of them is accepting a program, and the other one is accepting a builder. And I think eventually they should merge together, maybe. So maybe that would be the first order of business, actually, because that will simplify my life later on. So I will mark this so I don't forget where it is. Let's try to get rid of this version and see how it goes. So it will be, if I want to make it the same as the other one, it takes a scope, and that's pretty easy. It's just going to be program global scope. And then it takes a function builder star builder. And for these things, they are just not going to use it. So we will pass null for now. I think long term, even top level scopes will have some code associated with them that is going to be run at the start of your program. I still haven't decided if it's a good thing or a bad thing to allow that, but we'll see how it goes later on. In C++, for example, this is a code that is associated with constructors, so we have a global object. Though that code needs to be run at some point, so it's done at the start of your program. But in general, for now, it's fine if this is null. Okay. Maybe I will even call it like that. I don't know. It's fine as it is. Okay, let's see what breaks when I do that. So obviously, this token force type breaks. And let me see what is the definition. Are we using program in this? Well, that is not very important. So here I could easily probably have a scope star scope, right? Because we're not using program anywhere else. And then I guess this program lookup type, I would need to change to scope lookup type, right? Do we maybe have that function already? No, we do not. Well, that's fine. We can have program lookup type and change it to scope lookup type. It will just accept a scope, and something like that. Okay, that seems pretty reasonable. Now I can pass in the scope over here, and we can pass scope directly to here, which is even easier. Program lookup type, yeah, it's called now scope lookup type. So that works out pretty well. And I pass in scope and 0. Actually, here I can even pass the builder, right? Because we have it. So, I mean, why not? And scope is, I guess, called function scope. Okay, that seems fine. Token force type, this accepts now a function scope. So it also technically means that we could have, like I could pass in program global scope. Like that's also an option to keep more current behavior, and maybe that's a better option. I don't know. I think it might be okay if we have local types. I mean, if it causes problems, we can roll it back and only allow types to exist at the global level, but I mean, why not? Even in C, you can technically have types at the local level, right? Because I can write this stuff. I can say struct foo, or, you know, s32 foo, and then bar, something like that. That's perfectly valid declaration. It will complain that it's not used or something, and complain about this stuff, but it's perfectly valid, right? So I think it's actually even fine to use function scope. Let's see if that actually works out. Okay, it seems to be all fine. So I want to change this token rewrite. I want to get rid of that. Where are you? Yeah. So you go away. I don't want to see it anymore. And let's see what breaks from here. So this becomes token rewrite expression, token rewrite function. That's fine. We need to pass in the scope here. Yeah. It will complain about stuff, but we can deal with it. Okay, that it complains about the function itself. which we can fix. So now it will accept a scope over here, I guess. Scope and function builder star builder. Okay, this thing wants a program, but we well, you know, let's give it a program. So we will probably have to create a fake builder on the top level, but that's, as I said, that's perfectly fine. We will not really use it for anything for now, so that's okay. Okay, token rewrite functions. So the same deal here. Okay. Now this will just get a scope, so we didn't even need the program. That is good. I guess this also needs to be like this. Where are you using program? You're using program for import symbol. Ooh, yeah, so you will need to get program from builder then. Builder program. Okay, what about you? Well, you definitely also need a change in argument names. Token import match arguments. So this needs to do something. Actually, this is what I was looking at right now. And this stuff can actually stay as it was, right? Yeah, here it's actually fine. It is this one that needs to change. And then here I would say builder program. Something like that. Token rewrite expression, and then we can probably rename rewrite expression to just rewrite, but let's do one step at a time. And this is where I said I will need to create a function builder. So function builder, global builder, and function builder also needs to change. It needs to become something like code block or something like that. Something more abstract from the functions, and then it will be easier to assemble. Also will maybe required by the macro system later, but again, one step at a time. So we just start like this. Maybe I will just shove in the program here and say program is program, right? What else? Let's actually look at what we put into the function builder. So fan begin, yeah. Ooh, lots of stuff goes into here. Let's copy all of that and then throw away what we don't need. So I just want to have some stuff here to denote what we are importing. So descriptor will be none. That's perfectly fine. Function, that's also none. Prolog label, no. Function value, no. Program, stack reserve fields can be 0. That's actually not required. It's not required. Descriptor not required. Instructions. I mean, it's actually good that it will crash if you try to write it. So that's okay. We'll just leave it like this, right? And see what breaks, if anything. So you accept program global scope, and you accept the global builder. So that seems fine. Program. Yeah, I can actually rename you without underscore. Cannot convert function builder. Yeah, this needs to be like so. And at least it builds. Let's see if it runs, but I don't expect to have any problems really. Yeah, so that was a very nice refactoring, nothing really fancy, and it's a bit of a hack over here, but as I said, long term it is gonna possible that to add stuff to the startup of the program, so we'll need something like that eventually anyway. Now that that's done, that means that we have one signature for the kind of the callback, right? So we can say that we would have type def token pattern callback, and this thing will accept, it's actually going to accept something different. It's not even going to accept state. Instead, actually I already forgot the syntax for this. It should be like that, and then it will accept dynamic or array of token pointer. This is what it will return. This is the arguments it will accept. Should it return it or should it just manipulate it in place? I mean, whatever. If it wants to return a new one, it will return a new one. If it doesn't, that's okay. Cool. Do we even need then token match result? I guess not really. We can say token rewrite pattern, and this would be even void, I guess. And what this will accept is it will accept this state. It will accept array token pointer star pattern, and then the pattern actually will become something different a bit later, but for now, for what we are using, this is okay. And it will accept this token pattern callback. And here's what it will do. So it will start this pick index, and then it will not use the macro. Instead, we will use whatever macro is pointing to. So let me look that up. Define token match. So this just says token ID. Yeah. Okay. That seems fine. So we do this and we say for u64 I is 0, I is less than dynamic array length of pattern. Actually, I probably want to assert that the pattern has a length, because otherwise it would be a bug in the program somewhere. So something like this is good to have. K plus I, then I'm saying something like that. And then we say array token pointer star match is dynamic array make, and then we can say array token pointer, and we can also say that capacity of that is gonna be, okay, let's have this in a variable, so pattern length. It's also not gonna stay like this for long, I think, but for now Makes sense. Okay. And here, how do I want this? I want to have a label called cleanup, and I will say dynamic array destroy of match. Technically, I could make match static and not deal with creating and destroying memory. That will mean that, yeah, it's not going to be re-entered. No, I don't want to do that. That's fine. We'll make it like this. Okay. So now I say if not, this will be something like token. If we didn't match the token, then we go to cleanup and we kill the array, right? Here we can actually, so let me think about this. Yeah, we can make it smarter because we are always matching from the start. And if we are always matching from the start, that means that we just need to, yeah, that's fine. So we can do it like this. We can even return bool and say return false, like we didn't match. And here we say return true. Something like that. Okay, so here I will just say dynamic array get of pattern I, and say that pattern item, actually no, this is the token, this is fine. If not token, return false. Otherwise we continue, and if it works, then what? Well, then we need to call the callback, right? So if we finish that loop and we didn't already return, that means that we successfully matched what we wanted to match. And then we can say callback of dynamic array. I'm not sure if I have this function. Maybe I will need to make something like this. Oh, I don't have. Do I have like sub? I also don't have that as well. That's not great. So I have copy, but I don't have a copy that is sort of partial. Okay, well, I guess I'll have to do it myself. It's fine. That's not going to be too terrible. This actually needs to be not a pointer. So array token pointer match is dynamic array make of array token pointer, and capacity is what? Well, pattern length, right? Then I go through this again. I didn't need this peak index, by the way. And I will say that we have just token peak. It's actually not peak index. This is I, and we don't need plus plus, right? And like this. Yeah. And I say match dynamic array push match token. something like that. So we could fold these two loops into one. This is what I wanted to do in the first place, but then the problem is it's going to be ridiculously inefficient because we will have a ton of false matches, and for every false match we will generate a new array and then just throw it away, and it's just really bad. So even though this is a bit more verbose and we have to iterate over them multiple times, in reality it is better to do it that way. Okay, so we are callback, we passing match. This also needs to have a scope and a builder. So let's pass them here. We say scope star scope, and function builder star builder, and we pass in match, scope, and builder. Now we have array token pointer replacement, and this basically will be automation of where is this stuff? Yeah, of basically this thing, token replace tokens in state. So it's gonna be like that. Where is the stuff that I'm doing? So something like that, except we probably will need to write it ourselves. So let's just see what it does. So yeah, let's see how it would work. So instead of +1 and -1, from is the start index. That's correct. And then we don't need if. We would just say that there's going to be this min-max logic that always escapes me. So we have multiple cases. We can replace tokens with less tokens that we originally started with. We can replace with the same amount, and we can replace with more. And all of those need to work. And to be efficient, we don't want actually, if we get the same amount, we don't want to do two operations. We just want to remove excess, or we want to insert extra. And I'm not even sure that I can insert multiple things at the same time. Dynamic array insert internal, insert. So it's, yeah, we can only insert one at a time, which is a bit unfortunate, but I guess it is okay for now. So I will add a fix me and say support replacing with more tokens. And for now, I'll just do assert that dynamic array length of replacement is less than dynamic, actually, that we have pattern length, something like that. From is fine, that can stay as it is, and then well, let's actually create a variable here, maybe a bit above, and say u64 u64 replacement length is this stuff. So less or equal is perfectly fine. From plus replacement length and length minus replacement length. So length actually needs to be something like u64 deletion length is pattern length minus replacement length. And here state start index plus replacement length. Okay, that seems reasonable. So we replace from to, and then we take this stuff. This is actually not necessary. And we overwrite the replacement. So token is a dynamic array get of replacement I. And then I will say that star dynamic array get of state tokens, and then state start index plus I. And this is token, not double equals, but just equals. So something like that. Okay, what are the problems? Token star differs, that's okay. This is very easy to fix. Length is undeclared. Okay, and here's the same deal, needs to have a star. Okay, token peak too many actual parameters. Yeah, here I don't need to provide the pattern, I guess. Cool. Well, that's built. The question is, does it work? And the way I want to test it is I'm just going to replace one of them, not this one, I think, because it is slightly different. It actually returns match, which is something that needs to be cleaned up. But I want to probably do this thing, maybe. That would make sense. So here it actually does make sense to have array value pointer to be static because the pattern doesn't actually change, and this should be even more efficient than what we are doing at the moment because they only happen once. But let me think if I can make it fully static. Okay, right now I will do the following. It's not the best, but initialized of pattern. Then I will say pattern is dynamic array make of array. Actually, this should be token pointer, not value pointer. It's wrong. It's like this. Okay, and we just say dynamic array push of pattern, and then what? Ooh, so this is gonna be again static args, and this is token args is the following, right? We just say that type is, so basically this stuff. I can copy paste that, and then we push in args. So it's a bit more verbose, but we can clean it up with macros. That's not a problem. Arrow and body. right? Yeah, that seems good. Body doesn't have really any fields to speak of, which is something that can be cleaned up later anyway. Body, arrow is token type operator, and source is slice literal of arrow, right? Something like that. I think I need to do it like this. Args, arrow, body. I forgot return types. That's fine. We can add return types over here. Okay, this is return types, and return types should be paren. Okay, so that replaces sort of this part, and then we take this thing and we say bool token rewrite functions callback or even pattern callback. That gets it like this. And we don't need to make this thing. Instead, I want to say token return token pattern. How did I call it? Already forgot. Token rewrite pattern. Okay. Token rewrite pattern, and it gets the state, it gets the scope, it gets the builder, and it gets this new callback, which is this thing. It gets like this. Okay. We need to pass array value pointer match, right? Okay, and it needs to return an array value pointer. Okay. So let's first clean up this part, and then we'll clean up extra things. Is it not named source? Seems to me it is named. I need to have a dot, and this is no longer the right thing, and cannot convert array value pointer. Yeah, I don't need to pass state. I need to actually no, maybe I'm confused. I need to pass pattern, I guess, or maybe not. What does it take? Token rewrite pattern state scope builder pattern callback. Okay, so state scope builder pattern callback. Okay, so that is good. And the result token value pointer. Well, I can actually reuse the same array. I think that will work fine. Maybe. Will it work fine? I want to check something. So here's our pattern. This is a match. Yeah, we are not reusing match at all after the callback. That means that callback is free to return the same array that we passed to it. And also that actually means that we can destroy it. An array destroy of match. So that's pretty nice because it will be cleaned up. Maybe that's what we always will expect it to do, to return it. But if it always expects to return it, then maybe it is better to, I don't know. It's fine. Okay, so array reset of match. And here we need to basically do destructuring, which C obviously does not support at all, like in any flavor. Maybe that's something I can hack together with macros. Maybe, I don't know. So for now, this is gonna be a very manual thing, and you will be wondering like, why are you doing it? Like it looks like we added much more code than it was there in the first place, and it is true, but the gist of it is that here we will be able to create these patterns, as I said, declaratively, and parse them out of the source code and have new macro definitions that way. So let's get back to this thing. Parent, that's fine. We actually need to only get args, return types, and body. So args is dynamic array get of match 0. This is return types is 2 and body is 3. Okay. That seems fine, and we can use, I don't know, body for this thing. Temp, this needs to be a star. Star. Is it not called reset? Maybe it's called clear. Yeah, it's called clear. Clear of match and dynamic array push match result token. Value pointer, no, this is array token pointer. What am I thinking? It's called isInitialized, and it must return the value. Return match. I can't type today for some reason. Maybe it is too late for me. Okay. So that's a lot of typing. Let's see if we need to fix something up. And we do need to fix something up. Where are you failing? Where are you failing? At line 1205. So in the module, we end up with a bunch of stuff that we weren't expecting. Well, what was there before? Git diff source. So how did it look before I started all of that? Function, pattern, callback, rewrite functions. It was basically doing the same thing, I guess. Okay, well, time to get trusty debugger and see what is going on. We need to remove this breakpoint, and I guess we will start here. So F5. It's not initialized, so we create a pattern. That's fine. We push arcs, we push arrow, and I already see a bug, and that's probably what is problematic. We are expecting 2 arrows in a row. That's definitely not something we will find in any of the source files. Okay, so we are getting a different error, and what's happening here is that we get out of bounds read. Okay, let's do that again and see where that is happening. So that is happening on token rewrite pattern. Yeah, so that's totally fine. That is a bug. Where was I? Okay, I'll just fix it here. This needs to be replacement. Okay. Oops. We are somewhere over here. Yep. Good. Another try. And everything is succeeding. Good. So it's not much in terms of new functionality, but as I said, the most important part here is that now instead of code driving this matching, we can also have it being driven by some defined pattern. And that means that I would be able to have some way to define that pattern inside of the source code and say to replace that pattern with a different pattern, which is essentially what macros are. So that's going to be something we do in the future. For today, that's it. I thank you very much for watching if you made it this far, and hopefully see you next time.